We're going to look at solving a system of linear equations. Each linear equation represents a line. When we have a system of linear equations, we're going to have a system of two lines. In most cases, if we think about it, two lines very often intersect in one point. But two lines don't intersect in one point when they're parallel. So you could have one line and then the other equation can give you another line and they're parallel. So that has no points of intersection. So in the usual case, we have one point of intersection. That's most of the time two lines will intersect in one point. But when they're parallel lines, there's no points. There's no point of intersection. I'll abbreviate that. No point of intersection. And I'm abbreviating. There's actually a third example. You could have a line. That's one equation. But you could be given another equation which is the exact same line. So when it's the same line, you have infinitely many points of intersection. So infinitely many points of intersection. And I'm abbreviating this. As an example, I am going to give you a simple system of equations. The two lines are y equals negative 2x plus 4. That's one line. And the other line is 7x minus 2y equals 3. This is called a system of equations. Looking at this, we see that this slope is negative 2. Looking at this quickly, this slope won't be negative 2. So they're not parallel, and they don't look like the same line. So there will be one point of intersection. And we're going to do a method called the substitution method. To do this, we're going to have one line. We're then going to intersect it with the other line. And the way we intersect it, we take what y is in one line, and we're going to substitute it in to the other line. That way, we're going to intersect the two lines. So what is going to happen here is I have this problem, 7x minus 2 times y equals 3. I'm going to take the y from the other line and substitute it in for y in the second equation. I now have an equation having substituted one line into the other. It's going to tell me the x-coordinate of the point of intersection. So I'm going to work this out. Working this, I get 7x minus 2 times negative 2x is negative times a negative 4x minus 2 times 4, negative 8, is 3. Combining like terms, I get 11x minus 8 is 3. Combining like terms, we get 11x minus 8 is 3. Then we add 8 to both sides. That gives us 11x is 11. Dividing both sides by 11, we get that the x-coordinate for the point of intersection, the x-coordinate is 1. Now to get the y-coordinate, we just take the 1, which is on both lines, and we go up here to the first equation. And this tells us the y-coordinate is negative 2 times 1, the x, plus 4. So we get y is negative 2 plus 4 is 2. We now have the point of intersection of the two lines, and it is the point 1, 2. This is the substitution method because usually in this method you have either y equals or x equals, or you're able to get it, and you substitute it into the other line equation. I'm going to go to the next page and we'll do another problem solving for the point of intersection given a system of equations or two linear equations. Now we're looking at a different system of two linear equations. 5x plus 2y is 1, x minus 3y is 7. I still want to do the substitution method. So in order to do this, I have to look at one of these equations and convert it to either y equals or x equals. I'm going to use the second equation. Let me call this equation 1 and equation 2. So my second equation, x minus 3y is 7. I'm going to convert that to an x equal equation. Adding 3y to both sides, I have now made that the equation x is, and I always put the y term first, 3y plus 7. To solve this system, I'm going to take that expression for x and put it in for x in the first equation. That's how I intersect the two lines. So I'm taking equation 2, which has been rewritten now as x equal, and I'm putting the expression for x in equation 1. So equation 1, I have 5 times x plus 2y is 1. I now put the expression for x in the parentheses, 3y plus 7. I now can finish this, which will give me the y coordinate for the expression. This becomes 15y plus 35 plus 2y is 1. Combining like terms, I have 17y plus 35 is 1. Now I can subtract 35 from both sides. I get 17y is 1 and negative 35 is negative 34. Dividing by 17, I get y is negative 2. So now that I have y, it's very easy to go to the x equal expression. So if I go back so you can see, I'm going to put the negative 2 in there. Working that through, I get x is 3 times negative 2 plus 7. Negative 6 plus 7 is 1. X is 1. And we write the solution. We say the solution to this system is 1 comma negative 2.